Welcome back. You and I are working on this chess game. In the last episode, we worked on building out the game and sort of like some of the play loop logic where you can pick a piece up and move it around to another part of the board. We talked about dependency injection and a couple other really cool things about object-oriented programming. What I wanted to do in this episode was talk about seeing if a board is in check. So how do we figure that out? Well, in chess, right, like you are in check if your king is in danger. So if your king is in danger, that in our like world, right? So a piece has some set of moves. So we've got steppable and slidable, right? And if the available moves of a piece of one color includes the position of the king of another color, then the king, the person whose king is in the available moves of a piece means it's sort of like in danger or could be killed. So that would put them in check. So I think what we want to do is add a method to the board class here to see if a piece is in check, or if a player is in check. So we want to do like in check here, and basically the logic for in check is going to be something like I guess we need to pass in the color to see if like is black in check or is white in check. And the way that this will work is we're going to say like loop over all the pieces of the opposite color, and if any piece has an available move with the position of the king with color, then color is in check. So we want to loop over all the pieces of the opposite color. So how do we do that? I think it would be handy if we had some way to get all of the pieces from our internal representation here of the grid. So we want some way to get every single piece. And because our grid is a 2D array, there's actually a helpful method here in Ruby that we can use. So if we open up IRB, not IRP. So if we open up IRB, let's take a look at the flatten method on array. So our grid here, grid is a 2D array where we have like some elements in the array. These happen to be pieces, and we might have multiple. Yeah, we're gonna have multiple arrays, like one for each row on the board. There is a method on the array class called flatten. So if we just looked at the grid here, we can say grid.flatten, and that would give us back every single element that from the subarrays flattened out. And it turns out this works even if you have like sub-subarrays, right? So if we put like one in the sub-subarray here and say grid.flatten, then we get back a super flattened out thing. I think you can even pass this levels. So you can just say like flatten 1. That'll only flatten it down one level so that you don't end up flattening this sort of like subarray that's over on this level. If we say flatten 2, then it should flatten them all. So you can sort of use this flatten method and pass it arguments if you want, or you can just say flatten, it'll give you like the whole list of things. So if we said like flatten over here on our grid, then we should get back basically the list of all the pieces and a bunch of nils. So in order to remove the nils, we can sort of just do something to exclude those. So maybe let's make a method here, pieces, and we're going to say grid.flatten reject piece.nil. I think this should give us back all the pieces, maybe. We can go check this out and say we've got our start chess, and then what if we like print out, if we print out b.pieces, we should just get a bunch of pieces back. So if we run this, and again, this is going to be just like a single array of pieces that allow us to work through this. Look, okay, so we don't want to use p, we want to use puts. Because now that the pieces have reference to the other, they have reference to the board has reference to the other pieces, so we get a pretty nasty output there. So puts b.pieces, look at that. Okay, perfect. So this is going to be all of our pieces on the board, and that works great. And then we could do something like pieces dot select like P, where p.color is black or something, to get all the black pieces. So that should, I think that should work fine for finding like all the pieces of a given color. And maybe we want like a convenience method that's like, give me all the black pieces, but oftentimes we're going to be working directly with a color as a variable. So let's just jump back into game and mess around with this even more. So I'm sorry, back into board. So we've got our pieces. So we want to loop over all the pieces of the opposite color. So we want to say like pieces.select where the piece.color does not equal color. So that should give us all the pieces of a different color. .each do piece. And then we want to see if any of those available moves has the position of the king. So it's something like piece.available moves.include the king position, and then we need to figure out how to find the king position. So if any piece has an available move with the king position, then we return true. So if this return true, we want to explicitly use return here to just like break out and return, yes, we are in check. That king is in check. Okay, yeah, I guess that's a continuation of this comment here. And then otherwise, if that's not the case, then we're going to return false by default. But we don't know what king position is yet. So we need to figure out what the king's position is. So let's see, king pos is going to be, I guess we want to find from, I guess we can use pieces again. So we can do pieces dot select where the pieces, color is equal to the color that was passed in, and the pieces, or the piece dot class is equal to king. Or we can do like p dot is and pass in king. So is this is one of the ways that you can check what kind of thing something is. So is checks the class of the underlying instance. There's also a couple other things that this does, like it'll go up, I think this will go up the inheritance chain. So if you can say like, if it's a piece, and technically it's both a king and a piece because the king inherits from piece, but this should give us the piece itself, and then we want to say dot location, and that'll give us like the location of the king position. Okay, I think that looks fine, maybe. All right, so now in order to test this out, rather than just like starting up new chess here, what I think we want to do is just say board.new and then stick a white queen and a black king, and then check to see if it's in check. So we want to say like be at like, 1, 1 is going to be a king.new, and it's going to have the board, and it's going to be at 1, 1, and it's going to be black. And then we will create a queen, and a queen can move everywhere, and she will be at 2, 2. And this queen is going to be a white queen, and then b dot in check for black should be true, and b dot in check for white should be false, because, well, there is no king position for white. Sure, let's just grab this and then make a white one that's at like 6, 6, and we'll say it's a white. This is going to be a white king. But we are going to need to handle the case where there is no king of the opposite color on the board, which is an exceptional case, right? Okay, no undefined method location for array. Okay, and this is on board, in the board class, again on line 57. So go to board, line 57. No location method on select. So select is going to filter down the pieces and return an array. So I think we might want to actually do find. Maybe it's find by. Let's see. I can't remember if it's find or find by, because we wanted to return an actual instance. Is it find? Let's see. Okay, there we go. True and false. So that is exactly what we wanted. Black is in check, white is not in check, and we got that working just fine. The other thing that we wanted to do here, though, was say like, I guess this is going to fail if it doesn't find anything because it's nil. So, I mean, there's like this optional chaining thing that happens, or that we could potentially reach into and use, but let's just say this is the king. We'll say this is the king, or maybe king, right? And then if king.nil, and then we'll say king pause is equal to king.location. So if the king is nil, then we want to raise an exception. So we're going to say raise, this is like probably never going to happen, or shouldn't happen, right? If you are playing a normal game, because the game will be over as soon as we get to checkmate, which is that the king would has no way of moving around. So if the king is nil, then we want to raise like no king found. Sure. Okay, so let's run this again just to make sure we have still true and false. We didn't break our code. All right, so we've got in check working, and we're finding the king position for this given color. And then if it's nil, we're raising an exception. We're grabbing the king position. We're looping over the pieces, right, and checking to see if the available moves include that king position. Now, the next piece that we might want to do is checkmate, right? So we have in check. Now let's do checkmate. And this is also going to take in a color. And the thing about checkmate is that it's impossible to be in checkmate if you're not in check. So let's return false if you're not in check for that color. Otherwise, what do we want to do to be in checkmate? Well, I think what we might want to do, if every single piece is unable to move, because, okay, so what is checkmate? So checkmate, I think, is when you are unable to move at all and you are in check, and even if you move a piece, you're still going to die in the next move, right? And so how do we want to implement this? I think we might need to do something where we what do we want to do? Because when we're looking at available moves, right, the available moves so far does not consider anything about checkmate or being in check. So at this point, you can move anywhere that this piece could, like, based on the piece's possible directions and whether it's like slidable or steppable, it can move anywhere. But we are not disallowing making a move into check. So I think what we want to do is add another method to piece that checks to make sure that not only is the piece available, but it also like doesn't put you into check. So I think we want to add some other method to piece that says like we need some like higher level method that doesn't let you move into check. So let's go into piece and yeah, so we have available moves. So what if we just said like def valid moves or something like that, or like safe moves. And this is going to tell us, like, it's going to look at all the available moves. What is this going to do? So it's going to like look at available moves, and it almost needs to try every single available move and make sure that it doesn't move you into check. So like you kind of need to go over every single available move and temporarily like move to that position, see if you're in check. And if it does move you into check, then you cannot, that should not be included in the like resulting moves. So this is going to be like another array where we're going to return some list of moves at the bottom. And we're going to iterate over the available moves. So available moves that each do move. And we want to see, like, we need to like try the move, and if in check, if not in check, then like add the move to moves. So how do we want to do this try the move thing? Well, I think what we might want to do is, like, technically we could like sort of move to that spot. We could move the piece there and then move back, or we could duplicate the entire board. So we could get like a copy of the board, try the move on the copy, and if we're in check, then we don't include it. That way we don't have to like worry about moving the piece and then moving a piece back. So that also brings up some interesting stuff with the board. So if we wanted to duplicate the board, there is actually a method on Ruby objects called dupe, right? So if we can go to like IRB, if we had some like x is equal to the string test, if we say x dot inspect x, or let's say x is player dot new, no, x is let's see, require relative lib slash player dot new black. Okay, so then like I think player dot dupe. Yeah, okay, so this will actually create a new player object, a new instance. So you can tell because the memory address is changing here, so we're getting a different instance. So dot dupe, I think, is just a method on every single instance in Ruby. Like it just like comes with an object, but we can rewrite this, or let's actually just play around with it and see what happens with the board. So if we said require relative lib slash board dot rb or whatever, and then we say b is board dot new or board dot start chess. Oh gosh, let's do this in main over here. So if we were to say b is board dot start chess and then b dot dupe, right? And then we want to print out like b, or yeah, let's make one of these things, dot new with b dot render. Let's take a look at what we get. So this is rendering out the dupe board is equal to this thing, and that's what we want to pass into the renderer. Now, if we move a piece on the duplicated board, dupe board dot move piece from 1 1 to 2 1, and then we render it again. Oops. Then let's also render the original board and see if we can tell any differences. All right, so let's say puts dupe board after move, and then this is going to be puts original board after move. All right, let's run this. Okay, so the duplicated board after the move, this is what we expected, right? We're moving the piece from 1 1 to 2 1, and it's moving the piece, that's right. And then the original board after the move. So the original board, we're moving the piece on the original board also. So that is not actually duplicating the underlying grid. So we're not deep duplicating. So in order to deep duplicate, we probably need to write our own method here. So let's write our own method, like at the very bottom here, we'll say def dupe. And what do we want the duplication method to do? So this should give us back a brand new board. So new board is going to be board.new. And then what we want to do is go over all of the pieces in the current board class, which we have a method for that, pieces dot each do piece. We want to return the new board at the end. And what we want to do is on this new board, we want to set it up so that it has the same piece, like the positions of the same pieces. So I think we can do new board at piece.location equals piece. Oh, but we want to have new instances of the pieces too, because those are going to be moved around. So we actually need a new piece. So new piece is equal to piece.class.new, and oh gosh, what is this taken? So piece.class is going to be like king or pawn or queen or whatever, and then this new method takes in the board, so new board. It takes in the location, so piece.location, and it takes in the color, piece.color. Wow, okay, so this is cool. This is cool. So this should give us a brand new piece class, or like a duplicated piece class. And then we don't want to put the piece, we want to put the new piece onto the new board at the old piece's location, which, I mean, technically we can do like new piece.location just to be safe, and then we're going to return a new board. So let's rerun our test here and make sure that the original board is not modified when we are calling dupe on it. Awesome. Okay, so we have a duplicated board, and that's where the move happened. We have our original board, and there was no move that happened here. Fantastic. All right, so this is like how we would implement like deep duplication. And the reason that we need to do this is that the underlying objects here, so like all of this grid, this like 2D array, is when we're duplicating the board class, we're still maintaining reference to the same underlying array. And so we need to like create a whole new set of arrays and a whole new board and new pieces and everything. All right, so now that we're able to duplicate the board, if we go back into our board class for checkmate. Oh no, we were going in piece, right? We're trying to define valid moves. So we want to try the move. So we want to like duplicate the board. So from piece, I guess we could say like new board is board.dupe. And then we want to say new board.move, new board.move piece from our current location to the move. And then we want to check like if new board.inCheck for our color. So if we're in check, so if we're not in check actually, so if we're not in check, then we want to add to the moves. So let's see here. We want to say like moves, we're going to shovel in the move. All right, cool. Then the move is valid or safe or something, whatever. Okay, so this safe moves is going to be, this is like available moves that don't also move us into check. So let's just add a little comment here. So like available moves that don't move us into check. Okay, so back in the board class, when we're checking if we're in checkmate, we want to see if, yeah, I think we might actually want to use like safe moves here. And we probably want to use that in a bunch of other places too, right? So when we move the piece, we shouldn't actually be able to move it unless it's a safe move. And where else do we have this? Available moves. Okay, let's move that, change that to safe moves. Available moves. Okay, so I don't see it anymore. I do, nope. Available moves, no, okay. Cool. All right, so let's assume that that is looking good. Okay, why don't we see if we can figure out how to, what do we want to do? Well, we want to put, yeah, I think we want to like put the game state again into a state where we can check to see if we're in checkmate. So if we put the king like in the corner, and then we put a rook and a queen next to it somewhere. So B at like 0, 0 is going to be the king. And this is going to be the one that's in check. So we put it at 0, 0, or this is going to be the one that's in checkmate. And then we want to put the queen at like 2, 2 or something, or like 2, 2, 0. Let's put a rook at 2, 0. B and 2, 0. And this is going to be white. We also need a king. Let's put the king on the other side all the way across. And we'll make that a white king. And then we need another rook. So if we have one at 2, 0 and one at 0, 2, I think, or 0, 3, I don't know. Like that should make it so that we have one rook that can go this way and one rook that can go this way to kill the king. And then let's also put them 3, 0, actually 3, 1, I think might also work. Yeah, I think that should work so that the king is in checkmate then. So now if we say B dot checkmate for black, is that true? We definitely should have some automated tests for this. We need to rewrite this with Ruby. Okay, so block and initialize is too deep. Block in safe moves. Okay, so all right. Board on line 28. We have, okay, when you see this stack level too deep, it means that we're calling like functions and we're getting into some sort of like recursive loop that's going like way too deep. So if we go into board 28, I made a change here to available moves that we should not have. I'm sorry, to safe moves that we should not have. So, okay, yeah, so this one, wait, no, safe moves. If the safe moves include this, but we can't use safe moves inside of in check because in check is used when we're checking to see if a move is safe. So available moves. Oh, right, okay, return false if we're not in check. Otherwise, we need to see if the pieces of this color have no safe moves. So if pieces, we're in the board, dot select the pieces where the piece dot color is the same as that color. Now we want to check if any of them have, how do we want to do this? Safe moves, right? So this should give us the pieces. Let's just say like color pieces. No, let's just say pieces.select. Yep. So that's going to be like all the black pieces or all the white pieces. So now we want to go through all of those pieces and see if any of them have safe moves. So color pieces.any piece.safe moves.length or like dot empty. Should we check to see if they're all empty? Right? If the pieces safe moves are all empty, then we should be in checkmate. Let's see if that returns true. Stack level too deep again. So board 28. Board 28. Okay. In safe moves. So this safe moves here, piece.safe moves should not be calling. All right, what is this calling? So let's take a look at the stack trace here. So all.each block and checkmate safe moves. So when we call checkmate here, so we're calling checkmate on the board. All right. And when we're in checkmate on the board, we're checking to see, are we in check? Return false if we're in check. Otherwise, give me all the pieces. And then if all the pieces safe moves are empty. So then when we call safe moves on a piece, then we're going to the piece class. And safe moves is going over available moves. and it's checking to see if that moves us into check. And I am not sure why this is not working, or why this is causing a stack level too deep. So where is the recursion happening here? So if we call move piece, is move piece doing something fancy? So in board, if we look at move piece, yes, safe moves. Okay, so now we're at a position where in order to move the piece, so move piece is a method that we're using in safe moves when we're trying to make the move on the duplicated board. And because we are using move piece on the duplicated board, then it's also using safe moves. So we don't actually want to use safe moves in move piece. So what I think we want to do is make another method that does this stuff that actually moves the piece. So let's make a method move piece bang, which will take in the start position and the end position, but it won't actually validate anything. Start, pause, end, pause. And this is where we're going to actually like move the piece here. But we're not going to validate anything at all because we have already sort of validated stuff. And then down here, we can just call move piece bang with start, pause, and end, pause. And then we can just use available moves here. And that should work, I think. Yeah? Oh, wait, no. So when we are figuring out safe moves, we want to use the move bang method instead of the move. Okay, yeah, so move piece bang. This should make it so that it moves without running the validation, and the validation is the thing that's checking if it's in check, and we don't care about that because we're going to check it here. So I think this might be what we want. That's super confusing, by the way. So hope you're following along. So move piece bang, undefined local variable or method piece for board. Okay, so if we go to the board on line 105, yeah, I didn't copy enough in here, did I? So board, let's see, board on line 105. Another like rule of thumb is to try to keep your classes less than 100 lines. This class in particular is starting to grow a little bit out of control. Start piece. Okay, so we don't want to set this to nil yet because we need reference to it. So there's actually like a really kind of clever way to like swap something for another thing. And so I'm going to move all these comments up. And what we're going to do is we're going to say start position, comma, self end position is equal to nil, comma, piece. No, nil, comma, start position. And this, I think, is like a fancy way of sort of just swapping elements. So we're saying like put nil in the start position and put what's in the start position in the end position. And this will like evaluate the right-hand stuff and like get this ready to go and then plop it in here. I think that's what's going to happen. I don't know. We'll see. So we run it. And then did you mean pieces? Because we don't have the piece anymore. So now we should just be able to use the end position. I think. Let's see. In check, no king found. Oh, fantastic. Okay, great. So now, what, why? Oh, 6, 6, 6. Okay. When it duplicated the board, remember when it's duplicating the board, it's using the positions on the pieces. And because we had these, I didn't like copy those over correctly. That failed. So now it's returning false, which I don't believe. That's wrong because this black king should be in check. So, oh no, because this is again wrong. So 3, 0, and 3, 1. Okay. Gosh. Oh, true. Fantastic. All right, great. So is white in checkmate? White is not in checkmate. Fantastic. Awesome. So then if we can say like in check. Black should totally be in check now. And then we run it and true. Okay, great. So now we have implemented check and checkmate, and we also implemented like board duplication and a few other things. So hopefully this is useful. This was a really juicy episode, and really kind of got into the guts of how the board works for moving the pieces around and duplicating the board and figuring out where things are on the board. So I think we're actually getting pretty close to having a working game that we could play, and it would actually tell us like if the game's over and such. We can go implement this in the next episode. We're going to come back and check to see who's won, who's not won, and then as we're taking turns, we'll check to see if the player is in check. So that should be fun. So thanks so much for watching and sticking around, and yeah, we'll see you in the next one. Cheers.